In this lecture, we will study the numerical problems related to the Chebychev inequality and Bernoulli's law of large number. Consider an example in which a symmetric die is thrown 600 times. Then find the lower bound for the probability of getting 80 to 126. For this, consider S, which is the total number of successes. Then the expected value of X is equal to NP, which is equal to this quantity, and the variance of S is NPQ, which is equal to this quantity. As the probability of success is 1 by 6, therefore probability of failure is 5 by 6. Now, according to the Chebychev inequality, which is given by this quantity, put the value of expected value of S and the value of standard deviation here. We will get this equation. The value of K should be taken in such a way that we will get the desired range of our event. Therefore, the probability of S lies between 80 to 120 is equal to this quantity, which will be the desired result. Consider another problem. To determine how many numbers of fair coin must be tossed in order that the probability will be at least 0.9, that the ratio of the observed number of head to the number of tosses will be lie between 0.4 to 0.6. In this situation, we will use the Bernoulli's law of large number. So according to the definition, we have this quantity and this. Since in the case of tossing a fair coin, the probability P is equal to 1 by 2, which is equal to 0.5. And considering any arbitrary value of epsilon, here we consider the 0.1. Therefore, this equation can be written as this. Since the probability is 0.9 is required, therefore this quantity should be equal to 0.9. Therefore, n is equal to 250, which is the required number of tosses for getting the probability at least 0.9. Consider another example. If you wish to estimate the proportion of engineers and scientists who have studied the probability theory and you wish to estimate to be the correct within 2% with probability 0.95 or more, how large a sample would you take? In the two different cases. Case 1, if you have no idea what the true proportion, if you are confident that the true proportion is less than 0.2. For the first case, we will use the Bernoulli's law of large number. According to the definition, the Bernoulli's laws of large number is given by this. It is given that the epsilon is 2%. It means equal to 0.02. Therefore, this quantity is equal to this quantity. This thing is equal to 0.95, which is already given in the question. Therefore, n is equal to this quantity, which is the required number of sample size. Now consider the second part. According to the Chebychev inequality, for the variable x by n, we have this quantity. Here the probability is less than 0.2. Therefore, p into 1 minus p, that is pq, is less than 0.16 and the epsilon is 2%. It means 1 by 50. Therefore, this equation becomes this and 0.95 is given. Therefore, in the second part, the sample size is equal to this quantity. After solving this, now consider another example. For the geometric distribution, p of x is equal to 2 power of minus x. For x is equal to 1, 2, 3 up to, then prove that the Chebychev's inequality gives this thing, while the actual probability is 15 by 16. In this situation, expected value of x is given by this quantity. After putting the values of x, we will get this equation, which is equal to this equation. Or we can write like this, where a is equal to 1 by 2, which is equal to this quantity. Now we will calculate the value of expected value of x square, which is equal to this quantity. After putting the value of x, we will get this, or we will get this. After putting the value a is equal to 1 by 2, we will get 6. Therefore, the variance is equal to this quantity. Hence, standard deviation is under root of 2. According to the Chebychev inequality, we have this. Now, taking the value of k equal to under the root of 2, we will get this, or we will get this. Actual probability. The probability of mod of x minus 2 less than 2 is equal to the probability of x lies between 0 to 4, which is given by this, which is equal to 15 by 16. These are the few examples or numerical problems related to the Chebychev inequality and Bernoulli's laws of large number. I hope you understand them. Thanks for watching this video. For know more about the statistics, please watch the other videos.